intern in RPG, and during my intern I was working on this small project called SSL Store, right? So when I went there, there's this pretty cool HashiCorp vault that's there. So I'll talk about what Vault is. So the thing is, so the need was at RPG we have API proxies, right? So we serve customers, and for different customers we have a set of SSL certificates. So whenever so we wanted a store where we could keep the certificates for different customers and then push it to AWS or let's say any cloud base whenever we need it, right? So this is what. So for that, for storage, we saw Vault was pretty good option. So what Vault is, it's a tool for securely accessing secrets, right? So a secret can be an API key, it can be certificates, it can even be username, passwords, right? So what made us choose this was, number one, it has a secure secret storage. So Vault has this logical, so it has a logical file system, right? So at the back end, on the physical storage, you can have anything. You can have a console, you can have in memory, you can have stored in file. So what Vault makes sure is all the encryption is done on the logical file system, and the physical file system never sees the decrypted data, right? So in this way, Vault is very secure. It keeps data secure. For the certificates, we need it to be secure for the private key, right? The other thing was it provides us an HTTP API. So Vault works as a client server, right? So it provides an HTTP API so that we can store data in the Vault, access the data from the Vault easily. And because it's an HTTP, it also has a pretty strong authentication system. So you can use LDAP servers to access it. You can username passwords to access it. So which is pretty useful, right? About how the SSL store was designed, right? So main architecture is there's the SSL store which is written in Golang, so that it can be used easily on different machines, right? And on top of that, we built an HTTP API so that we can interact with the SSL store, right? So so that different applications in RPG could interact and like use SSL certificates whenever it is required. And it's the SSL store which uses Vault and RDBMS. So we use Vault to store. We'll use Vault to store all our data, which is very sensitive, right? The private key and the certificate itself and things like that, right? And we use RDBMS so that we can store the metadata about a certificate. So we want to know what certificate belongs to the customer and that. So this is how the main architecture looks like for the SSL store, right? So here's one example. We can, is it clear? But it's just a flow, right? I just couldn't get the actual pictures because I don't have it right now. So the first box is the HTTP API, and the second box is the SSL store, right? So on the HTTP, you send a post request saying, I want to store this certificate for this customer, right? So you send in the certificate, the CA, the entire trust chain, and the private key to the HTTP API, which checks, there are checks involved in there so that we can check, okay, the customer is right, we're doing it for the right customer that we already have, or does this certificate already exist, is it a duplicate, things like that on the HTTP level. And then we send back to the SSL store saying, okay, go now pass the certificate and check if the chain is correct, okay, and then store it in the database. So the SSL store is responsible for sending the certificate to the Vault, right? And we have, so initially, like currently we have the file system as config file where we get the DB credentials and the Vault credentials, okay. And also if you want to upload it to an AWS, it's also in the config file. But Vault also provides one feature that we love to implement a little later, is that it provides you a way so that you can create AWS access credential keys on the fly, and also MySQL or RDBMS data, MySQL database username and password on the fly. So if that's set up, so we'll only need a Vault credential, and then everything else will be given to us from the Vault on the fly. That's like next. And here you store that Vault. You show the certificate to the Vault, right? So in here we have all the checks there, like okay, the private key should be correct, the same, like it should be compliant to what we're using. Trust is chain, the chain entirety is correct, and stuff like that. And also because at the end goal you want to upload the certificate to AWS, right? So this is example number 2, where I'll list out all the certificates I have for a customer, and I'll choose, okay, this is the certificate I want to upload to the AWS. So AWS has its own certificate store where you need to keep the certificate to attach it to an ELB, right? So what the flow is, you tell the certificate, tell SSL Store HTTP where this is the certificate name I want to use, this is the customer, and it gets the certificate and the key from Vault, and push it to the AWS. So still, as I said, the AWS creates in the config file, but in the next time we'll love to keep it in the Vault, because Vault has this thing where we can create on fly, right? That's it. That's how this works. It was an intern project, so it's not that big. So that's it. Thank you.